Good morning, Algebra 2. We are going to cover Lesson 43, Solving Systems of Linear Inequalities. Now, we've already gone over linear inequalities and how to graph them, and so I'm going to review that, and today we're just adding solving systems means we're just going to have more than one. So let's review a couple things. Inequalities means we have the following four symbols. These are inequality symbols because they don't equal. They're either less than or greater than. If I have the equal to symbol, then this means I'm going to graph it with a solid line. Just like if I do the number line, if I have the symbols, I use a solid circle. If I have two variables, x and y, then I graph it using a solid line. If I have less than or greater than, then I'm going to use a broken or dashed line for when I graph it. Another review is I have to shade one side or the other. Okay, I have to either shade above or below. Now I went over two ways that you can shade, and it's based on what form it's in. If it's in slope-intercept form, for example, that means you'd have y and mx plus b, right? So if I had y is greater than mx plus b, then I would shade above. If I have any kind of less than symbol, mx plus b, then I would shade below. Above, greater, below, less than. If it's not in slope-intercept form, or it goes through the origin, then I'm going to test a point. For example, the best point to test is 0, 0. Okay, so those are the two ways that I'm going to shade, okay? So we're going to jump right into our lesson practice, which is on page 314. I can't believe we're that far in the book already. And we're going to go over all the parts of this section. So let's jump into part A. It wants us to know if the following points are a solution. Determine if, and let's see where I wrote if negative 5, 0, comma, negative 6, 0, comma, 1, comma, negative 2 are solutions for the following equations. X is greater than or equal to negative 5, and 2x plus 3y is less than negative 3. Now, there are some test questions like this and homework questions. So how we're going to do it, these points have to work for both equations to be a yes. Okay, so they have to work for both. And you have to test one at a time. So I'm going to test negative 5, 0. So is negative 5, greater than or equal to negative 5? Yes. Notice I only plugged in the x value. And let me fix this parentheses just so it doesn't look so funny. Okay, now I'm going to plug it into the second equation. So 2 times negative 5 plus 3 times 0. Is that less than negative 3? Well, this gives me negative 10 plus 0. And that's negative 10 is less than negative 3? Yes. So negative 5, 0 is a yes. Okay, so the first one is a yes. I'm now going to move on to the second point. So negative 6, comma 0. Is negative 6 greater than or equal to negative 5? Yes. Next, 2 times negative 6 plus 3 times 0, is that less than negative 3? Well, this just gives me 0. This gives me negative 12. So is negative 12 less than negative 3? Yes. So negative 6, comma 0 also works because it worked for both. Oh goodness. You know how sometimes, I'm just going to wish I took this all back. Silly me. Is negative 6 greater than or equal to negative 5? No. So even though it worked for the second equation, it doesn't work for the first. So I would write no for this point. So sorry, I just saw the 6 and I was answering it fast. My apologies. So if you happen to have plugged it into the bottom one, yes, it works for the bottom one, but not for the top equation. So let's try that last point, 1 comma negative 2. So that first equation is our x value greater than or equal to negative 5. Yes, check. Now plug it into the second equation. Is that less than negative 3? So 2 minus 6. And negative 4 is less than negative 3? Yes. So 1, negative 2 is a yes because it worked for both equations. So if you're given a problem like this, you have to test each one and you have to plug it into both, and hopefully you don't make a mistake like I did here. All right, moving on. I believe the rest are all graphing. So if you have a ruler and graph paper, please make sure you can either download graph paper or you can purchase some at most stores. Okay? So part B says to graph the following system: x is greater than or equal to negative 5, and 2x plus 3y is less than or equal to negative 3. All right, so I'm going to start with the first one. So let me quickly draw. Here's a y-axis, and let me move my work over. And here is my x-axis. Okay. And I'm going to go ahead and color code these so that way you know which ones I'm referring to. Let me draw a couple lines on, or a couple numbers on here just so we can accurately graph. All right, so the top one is already in a good form. X is all by itself. The bottom one I'm going to rewrite. So 3y is less than, I'm going to subtract 2x. And then I'm going to divide by 3. So I'm getting it in slope-intercept form. So y is less than negative 2/3 x minus 1. So I have the bottom one in slope-intercept form. And I'll color code these in a second. So let's start with the top. So x is greater than negative 5. So on the x-axis, here's x, here's negative 5. And so I'm going to have a solid line because it's a greater than or equal to. And it's because it's greater, I'm going to shade the side that represents the x values greater than negative 5. So I'm going to look way over here. These positives are greater than a negative 5. So I'm going to shade to the right. Okay. Now the bottom one I will do in yellow, and I put it in slope-intercept form already. So my y-intercept is at negative 1, right? So at negative 1, here's my y-axis, here's negative 1. My slope is negative, so down 2 over 3. I'm going to go back and go the reverse, up 2 over 3, up 2 over 3. And I notice that this is less than. Remember, that's rise over run. So I'm going to draw a dashed line because it is not an equal to symbol or broken. Think of it as like the center line of the road, right? When you can pass cars. Now, because it's less than, I'm going to shade below. So using, and the solution area is where the two colors overlap. So this area here represents all of my solutions because it's where the shading overlaps. So if I was reading this, any point within the yellow-orange area is a solution. It cannot be on this dashed line. The broken line means it can't equal, but it can be on any point on this line or in this region is a solution. So there's more than one solution because it's any point in that area. All right, so moving on, I'm going to part C. Hopefully this pen doesn't die out on me. So we are going to graph y is greater than negative x minus 2, and x plus y is less than 3. So those are my two equations. The top one is already in slope-intercept form, so we're going to go ahead and graph that one the way it is. The bottom one, I'm going to subtract x, so y is less than negative x plus 3, and that'll be the second equation that I graph. So here we go. I'm going to draw my x and y axes. I have negative 2 and positive 3, so it doesn't need to be crazy big. So let's see here. Here's 2, 4, 2, 4. This will be negative 4, negative 4. All right, so let's start with the orange one. I have a y-intercept of negative 2. So on my y-axis, I have a point at negative 2. My slope is negative 1 over 1. So down 1 to the right, down 1 to the right, down 1 to the right. And I'm going to go in the reverse, keeping that slope of 1 over 1. And I have a dashed line. Now it says greater than, so because it's greater than, I'm shading above. So I would shade it this way. And obviously, I mean, you can color it all in, but up to you. And this goes way out here. I'm just only shading a little bit. All right, the bottom line, I've got a y-intercept at positive 3. So on the y-axis at positive 3. Now, because I'm doing these videos so thorough, you guys should be able to graph these on your test. Because that is less than, I'm going to shade below. And my slope, again, is negative 1 over 1. So down 1 over 1, down 1 over 1, and so forth. And then I'm going to go on the opposite, keeping the same slope. I'm going to use a dashed line. And I said that I would shade below. All right, so if you look here, all of the points in here are my solutions because that is where the two lines overlap. So any solution in between those two lines, any point between those two lines is the solution because that is where the two colors overlap. All right, moving on to the next one. So part D. And I have to turn my page here. All right, so part D is I'm going to graph the following. Y is greater than or equal to negative 3/4 x plus 4. And 3x plus 4y is less than or equal to 4. Okay, so I noticed the top one is already in slope-intercept form. And so we're going to work on the bottom one. All right, so I'm going to subtract 3x. So 4y is less than or equal to negative 3x plus 4. I keep it in order. This is negative, that's positive. Then I'm going to divide each part by 4. So y is less than or equal to negative 3/4 x. 4 over 4 would be 1. So there is my second equation. And so we're going to graph. I look at my y-intercepts. They're both above, so I'm going to leave room above on the y-axis. So there's y, so I'm going to make it to where it's like down here. All right, So let's start with this top one. I have a y-intercept, meaning it's on the y-axis at positive 4. I have a negative slope, so down 3 to the right 4. Down 3 to the right 4. I'm going to go back to my y-intercept and go in the reverse. Because it's equal to, I know it's a solid line. And notice I draw arrows, and I'm going to be shading above because it is greater than. Okay, so we're shading above. So I'm going to be shading above here. All right, my next line, I have a y-intercept of positive 1. So on the y-axis, positive 1. I have the same slope, so down 3 over 4. And I'm going to go up 3 and over 4. And it's also solid. But in this case, I'm going to shade below because it's less than. So I'm shading below. Now, in this case, the shading does not overlap. So no solution. There is not a single pair of points that is in both the yellow and orange region. Okay, moving on. This next one is a little difficult because they're going to give us 3 equations. So we're going to graph y is less than 4. 2x plus y is greater than or equal to 4. And x minus 2y is less than or equal to 2. So I'm going to use 3 colors here. So the top is already in like the form I want it. It's not really slope-intercept form because I only have one variable. The second one will be really simple. I'm simply going to subtract 2x, so y is greater than or equal to negative 2x plus 4. Right, I just simply subtracted 2x from both sides. This bottom one, I'm going to have to do a little more work here. Sorry about that. I'm going to have to subtract x. So now I'm going to write negative 2y is less than or equal to, write the x first, that's a negative x. That's a positive 2. And then I'm going to divide each by negative 2. Now, a lot's going to happen here, so pay attention. I divided by a negative number. Negative 2 divided by negative 2 is a positive y, but it flips my symbol. A negative divided by a negative gives me a positive slope of 1/2. But a positive divided by a negative is a negative 1. So be really careful there, and I'll put that one in pink. All right, so here we go. I'm going to graph all 3 of these. So I'm going to leave myself lots of space here because I have several lines to include. Sorry, I'm working with a different ruler today. All right, so let's label a few. Here's 4. I like to put at least 1. I make less mistakes if I have some numbers on my axes. I also like to label this as x, right? And this one is y. So this first one in orange, y is less than 4. So on my y-axis, I should have a broken line at 4, and I'm going to shade below because it's less than. So using my orange, I'm shading below. Hopefully I shaded enough because I haven't put the other lines on there. So this next one I'm going to shade above because it's greater than. I have a y-intercept at 4, but my slope, this is negative 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1, and so forth. I'm going to go back to my y-intercept and go in the opposite, so up and to the left. And this should be a solid line because of the equal to. And as I stated, I'm going to be shading above. Okay, so yellow one, done. Last one, I have a y-intercept at negative 1. I have a positive slope of 1 over 2. And so let me put, and it's also solid. Now I'm going to be shading above. Now something I noticed, and I kind of expect you guys as well. Let's say you find out, like looking at mine, I noticed I didn't draw this line out far enough. So I'm going to erase my arrow and I'm going to continue it so that it meets. Okay, so it closes in that shape. And then I'm going to shade above this line that I just drew. So above this one, make sure you track your work. And I notice that all three overlap right in here, right in this area. So that little triangle is where all my solutions are. And that, well, I shouldn't say little, and that triangle is where all of my solutions lie. Last one is part F, and I need another piece of graph paper. So if you just give me 1 second, or maybe I'll just do it on the back. I'll just do it on the back. Hold on, let me get one more piece. I don't want it to bleed through. All right, so part F on your lesson practice is a word problem. And I wanted to specifically do this one because I'm going to graph this one by shading. So on part F, let me grab your book. It says 2 of the ticket prices for a Major League Baseball game are $65. So $65 for the first one plus $12 for the bleacher seat. You decide to spend up to $500. So I put these all have dollars, but I put all the money in one equation. You don't need dollar signs, but just notice that I grouped all the money together. The next has to do with number of tickets. It says you decide to buy up to 20 tickets. I don't know how many of these MVP, I don't know how many bleachers, but I know that them added together, I want to spend up to 20. So it wants us to graph so we can show all the different combinations that are possible. So I'm going to actually use this form, and I'm going to graph using my y-intercepts. So for the top one, if I plug 0 into x, so I'm going to plug 0 right here, 65 times 0 is 0, so I'm left with 12y is less than or equal to 500, so I would divide by 12. And I get 41.7. If I plug 0 in for y, 12 times 0 is 0, and I'm left with 500 divided by 65, and I get 7.7. So for this top line, I'm going to graph these 2 points. Okay? For the bottom, I'm going to do the same thing. 0 in for x, 0 in for y. So if I put 0 right here, I just have y is equal to 20. If I plug 0 here, I get x is equal to 20. So for this bottom line, I'm graphing these 2 points. Now, the reason I'm using it this way is my numbers are so large, I'm going to end up with a really weird scale. I'm going to end up with a weird rise over run. So in this case, with big numbers, it's easier to use your x and y intercepts. So let's do that graph. Notice I'm dealing with real world problems, so I cannot have a negative number of tickets, so I'm not going to try that. I need to leave room for 40s. So I'm going to go by fives. 40, 35, 30, 35, 20, 25, 10, so 0 should be here. So I like to work backwards. That tells me how large my x and y axes should be. And down here, I will also go by the same scale. Okay. So x is number of tickets. Y is money spent. Okay? You don't have to label it that way, but whatever. So I'm going to do the orange one first. 0 and 41.7 and 7.7. So here, this is 5, 7.7 is probably right there. It's going to be solid because it's a equal to. And I'm going to shade below because I have, and I shouldn't have even written that. These are not in slope-intercept form. So for the orange, if I test 0, 0, 65 times 0 plus 12 times 0, is that less than or equal to 500? So this both gives me 0. This is true, so I'm going to shade where 0, 0 is. So I should be shading that side of the line. Next one, I have intercepts at 0, 20 and 20, 0. I have a solid line. I'm going to test 0, 0. So is 0 plus 0 less than or equal to 20? Yes. So I'm also going to shade 0, 0 is. So any point in this region is a possible solution for this problem. And that ends the lesson.